Good morning. We are studying in M. Kumarswamy College of Engineering, Karur. Our in final year, our final project is critical heat flux on pool boiling on nanofluid. Our team is M. Pratish, V. Nitin, and Pre R. Pranit. Our under of mentoring if Dr. T. Nityanandam, PhD, Associate Professor of the Department of Mechanical Engineering. Our other abstract is currently studying investigate the critical heat flux on pool boiling that the transfer characteristic hybrid nanofluid composer of magnesium oxide and zinc oxide nanoparticle are disappearing in 500 ml of distilled water, 3 different concentrations 0.001%, 0.01% and 0.1%, and analyzed. Pool boiling experiment were conducted on copper heating surface under atmospheric pressure to examine the influence nanoparticle concentration on heat transfer performance. The temperature measurement were taken using the thermocouple connected to the data acquisition of system. The coil was gradually heated by increasing voltage incrementally, which raises the copper surface temperature. Our introduction is pool boiling occurs when liquid is heated above boiling point in container and bubble form at the nucleation site on the heated surfaces. The process involves the liquid to vapor heat in transfer from the surface of the fluid. Stage of the pool boiling is nuclear boiling, critical heat flux of the boiling, flame boiling, and more literature review are analyzed in our project. What is pool boiling? Pool boiling is the liquid heat of the submerged surface resulting in the formation of bubble, the discharge of the rise through the liquid. The phenomenon on common various industrial applications such as boiler, nuclear reactor, and cooling system. Mostly used in the nanofluid type is aluminum oxide, copper oxide, magnesium oxide, silicon oxide, ceramic oxide, carbon dioxide are used in the pool boiling. Nanoparticle properties, chemical properties, magnesium oxide, zinc oxide, thermal conductivity, high enhance heat transfer in nanofluid, viscosity increase in nanofluid depending on concentration, density is 3.58 and 5.60 gram per centimeter cube, hardness is 9 per mole per cell scale. Electrical conductivity is insulator, thermal stability on up to 1000 degrees Celsius, chemical resistance excellent resistance to corrosion and oxidation. Surface tension is reduced, aiding the bubble. Of our project is nanofluid for cooling system and coating ceramics at catalysis fertilization. And the selection of the nanoparticles, thermal conductivity, stability, surface property, density and viscosity. Magnesium oxide and zinc oxide nanoparticle is commonly used in the increase the number of nucleation site, improve the thermal conductivity. The preparation of the nanofluid is selection of basic fluid or water and ethylene glycol or thermal conductivity stability. Synthesis of magnesium oxide zinc oxide nanoparticle is up to 10 to 100 nanometer. Concentration is used in 0.1% to 5% of weight. Methods of dispersion in our project is ultrasonication and magnetic steroid. And material specification is commonly used in the weight and density in per specification of concentrations and distilled waters. And the formula is volume concentration is and weight of nanoparticle, density of nanoparticle, weight of basic fluid, mass of nanoparticle, density of base fluid. And the experiment setup is heat surface of the flat smooth surface. The copper is used with the heating element. Surface is carefully polished in the distribution, heat source, thermal temperature measurement, nanofluid reservoir, cooling and flow circulation, data acquisition system, experimental procedures, and table calculation of our project readings and 3 concentration and execute our result of experimental graph of the 3 concentration. And the result is the magnesium oxide nanoparticle is increase the heat critical heat flux 30 to 40%, enabling the more efficient dissipation. The boiling heat transfer sustainability increase up to 50% of our nanoparticle volume, 0.01% of by volume enhance of the provide by enhancing the pool boiling in performance and management applications, mostly used in the high thermal conductivity compare the more efficient heat transfer. Overall the performance increase the heat transfer and critical heat fluxes. Our conclusion is enhance the thermal conductivity of liquid leading the more effective and increase the overall boiling heat transfer rate. Experimental study on the high critical heat flux and heat exchange our thermal management systems. Application in the cooling system, electronic device and other industries, mostly used in our project. Thank you.